Hello, dear student. Myself Arif Khan Pathan, Senior Lecturer, MC Society Institute of Pharmacy, Diploma Azam Campus. I welcome in this heterocyclic system part 2. In first part already we had seen this classification, that is heterocyclic compound, simple structure, fused ring structure and the bridge structure. We know that simple structure means in which the single ring is there and mostly one or two heteroatoms are there. Single ring is also called a simple structure. This is the first example, pyridine, in which the nitrogen is a heteroatom for 6-membered ring. Next, nitrogen is a heteroatom 5-membered ring, so single ring is called as pyrrole. Next, in which oxygen is a heteroatom and it's a 5-membered ring called as furon. Next, sulfur is a heteroatom and again a 5-membered ring, and also obviously it will be the single ring structure, and that is called as thiophene. That's why single ring simple structure. Next, fused structure, name itself indicating that there are two or more rings fused together to form a heterocyclic ring, that we call a fused structure ring. Maybe two or three rings fused together. In this case, we have an example of a quinoline in which the two rings are fused together. One is benzene and second one is a pyridine. Pyridine fused with benzene to form quinoline. Next example, we have fused ring structure, that is benzene fused with pyrrole. You can see the 5-membered ring pyrrole which fused with the benzene to form fused ring structure called as indole. So these are the two examples of the fused ring structure. Now next one, a bridge structure. You can see that in this ring, this part and this part, last one, will get linked by the amino bridge. You can see that the amino bridge is there, amino bridge. So with this amino bridge, these two parts are bridge or joined together. That's why this is called as a bridge structure. And this is the structure of the amodiaquine, which is an antimalarial drug. But these fused ring structure are least important. Mostly we have to focus on the fused ring structure as well as the simple ring structure as far as these topic is concerned. So there are why we are going to see these heterocyclic rings and the structure, because the large number of naturally occurring drugs contain heterocyclic system. For example, vitamin B groups is there, like thiamine, which is called as vitamin B1, riboflavin, which is called as vitamin B2. So these are this belong to the group vitamin B. So these vitamin groups or vitamins has the heterocyclic structure, heterocyclic ring in their structure. That's why we have to deal with the heterocyclic ring. Next, antibiotics, example penicillin is there, griseofulvin is there. This again having the heterocyclic ring in their structure. Next, alkaloids, rizerpine, pilocarpine, steroidal drugs, like for example cardiac glycosides, digoxin. These are again having the in their structure. If you see the structure of these drugs, will have some other part of heterocyclic ring. Maybe a 5-membered ring, 6-membered ring, or 7-membered ring will be there, or fused ring structure will be there. But basically these rings will be present in these organic compounds. Now next, the nomenclature. The first rule to give the numbering, that is how to give the numbering to the simple heterocyclic ring, how to give the number to the fused heterocyclic ring. One by one we'll go and we'll go through the rules, because there are certain rules to give the numbering and fixed rules are there to give the numbering to the heterocyclic ring, maybe 6-membered, 5-membered, whichever. So this the first rule knows that the simple heterocyclic ring containing one heteroatom, the heteroatom in the ring is counted as 1, and other heteroatoms are numbered either clockwise or anti-clockwise. So for that we have the example. There obviously we should have to learn, understand, take into consideration that this is for simple heterocyclic ring. Simple heterocyclic ring means the single ring. For example, the below ring is given, which is again a simple heterocyclic ring because it's a single ring structure. So definitely for these to give the numbering to this ring, the rule is applicable. Now what is the rule? The heteroatom in the ring is counted as 1. Position 1 will be given to heteroatom, and other atoms are counted either clockwise or anti-clockwise. So obviously this is the heterocyclic ring which has a nitrogen as a heteroatom. So we must have to start numbering with a nitrogen. Then we can go by clockwise, anti-clockwise way, that is 2, 3, 4, 5, 6, or clockwise way, that may be 2, 3, 4, 5, 6, like this. Both will be the correct way of numbering. because it's a simple heterocyclic ring. But the condition is that we must have to start the numbering with the nitrogen or any of the heteroatom in the ring. We have to start the numbering from heteroatom. Next example we have, this is the pyrrole, which is a 5-membered ring. So obviously simple heterocyclic ring, so obviously we should have to count the number 1, or position 1 will be given to heteroatom. Obviously nitrogen is a heteroatom, so nitrogen counted as 1. Then the freedom is there, either we can go anti-clockwise way, that is 2, 3, 4, 5, or we can start numbering with nitrogen and we can go clockwise way, that is 2, 3, 4, 5, 6. Clockwise, anti-clockwise, both will be permitted because there is no substituents on the ring. It's a simple heterocyclic ring. So this is the first rule. We have to count heteroatom as a 1 and then clockwise or anti-clockwise way. If it is 6-membered ring, the number will get extended to 6. If it is 5-membered ring, last number will be extended to, numbering will be extended till 5. That depends how much number of member ring is present. This is the pyrrole. Now next rule, this is again for simple heterocyclic ring, but if the substituent group is present, heterocyclic ring with one substituent, then substituent should bear the least possible number. That substituent should get the least numbering that the rule says or rule state. So we will take this example in which the simple heterocyclic ring with one substituent is COOH. So obviously first rule will be applicable to this, that we have to count the numbering, or we have to start numbering with the heteroatom because it's a simple heterocyclic ring containing one heteroatom. So obviously nitrogen is a heteroatom, we have to start numbering with the nitrogen. Then the numbering to this substituent will decide either we can go clockwise or we can proceed anti-clockwise. So if we proceed the numbering, that is 1 we had given to nitrogen, then 2, then 3, then 4, then 5, then 6. So now I had given the anti-clockwise way of numbering in which the substituent getting third position, COOH substituent on the heterocyclic ring getting third position. This is by anti-clockwise way. Same if you are going clockwise, so numbering will start with nitrogen, it will be 2, 3, 4, 5, 6. So in this case the substituent getting 5 position. Now as per this rule, if the substituent group is present on the simple heterocyclic ring, then substituent should bear the least possible number. Now in this example we can see that if you are going anti-clockwise way, the substituent getting third position. If you are going clockwise way, the substituent getting 5 position. So 3 is least number than 5. So this is the correct way of numbering in which the substituent getting least number. So in this case there is a restriction that we have to count the numbering or proceed the numbering by anti-clockwise way, so that the substituent will get the least number. Actually this is the correct way of numbering. If you are counting clockwise in which this substituent getting 5 position, so that is the wrong way of numbering. So next rule again, if in this case only the one substituent, if more than one substituent present on the simple heterocyclic ring, then rule state that they should bear, all the substituents should bear the list set of numbers, and these groups are arranged in alphabetical order. So let me have an example in which the simple heterocyclic ring will be there. We have to count with the nitrogen. Now clockwise or anti-clockwise will depend the last substituent getting how much number. Say for example, if you are giving clockwise way, the last substituent getting 5 position, and if we are counting anti-clockwise way, then it will be a 1, 2, 3, 4, 5, 6. So last substituent will be getting 6th position. So 5 is least as compared to 6. So as we had given clockwise way of numbering, that is the correct way of numbering, which gives that the last substituent getting the last position getting fifth position, that is least. And if the possibility is there that by either a clockwise way or anti-clockwise way, if the substituent getting the same position last, so in that case we have to go for alphabetical order. We have to find the alphabetical order, we have to follow the alphabetical order. Next rule, that if the heterocyclic ring containing 2 or more heteroatom, then the position preference for position 1 will be given in the order of OSN, that is oxygen, sulfur and nitrogen. If the ring is there in which the maybe these types of heteroatoms are there, one more than one heteroatoms, so position 1 will be given to oxygen, then sulfur, then nitrogen. So this will get clear, uh, and this will get clear by the next example. We see the example in which, now this is an example in which the 5-membered ring is there and there are two types of heteroatoms, oxygen and nitrogen. So either we have to start numbering with the nitrogen or with the oxygen. That depends or will decide by this rule, OSN. So oxygen and nitrogen is there, so position 1 will be nitrogen, will given nitrogen, then we have to proceed the numbering so that the nitrogen will get the list number. So in this case, the restriction is that by OSN rule we have to start the heteroatom numbering from the oxygen as a heteroatom, then we have to proceed by anti-clockwise way so that the list numbering will be goes to nitrogen. Obviously we should have the numbering start with nitrogen with the oxygen, and if we are going by clockwise way, so it will be 1 2 3 4. In this case clockwise way, the nitrogen getting 4 position, in anti-clockwise way nitrogen getting 3rd position. So we should, this will be the correct way of numbering in which the nitrogen getting list number. So by this rule, next example we can see that now in this example there are two heteroatoms, sulfur and nitrogen. By OSN, sulfur will get position 1, then the numbering will go to nitrogen, and again in the same way that the other heteroatom will get the lowest set of number. So in this case we have to start a numbering with a sulfur, and then we have to proceed anti-clockwise way so that the nitrogen will get the list number as previous. And this is the last rule. This is again the rule. If the simple heterocyclic ring containing 2 or more nitrogens, then the saturated nitrogen should bear the list number, that is position 1 will be given to saturated nitrogen. Now in this case we had seen there are two heteroatoms, one is nitrogen, second one is oxygen. In previous one, again in this example we can see that there are two heteroatoms, sulfur and nitrogen. So position 1 will be given or decided by this order, that is OSN, oxygen, sulfur and nitrogen. Now the next rule says that if both the heteroatoms are nitrogen, if there are two nitrogens are present in the simple heterocyclic ring, two or more nitrogens, then which nitrogen from which we have to start a numbering, so will be given by this rule that the saturated nitrogen should bear the list number. It indicates that the numbering we have to start with a saturated nitrogen. So in this case we have an example. This is a example, simple heterocyclic ring, 5-membered ring, single ring, two nitrogens are there, one is saturated, another one is unsaturated. Unsaturated means double bonded nitrogen. So in this case you can see that there is a double bond with this nitrogen. It means this nitrogen is unsaturated nitrogen. This nitrogen is unsaturated, and remaining one is with the single bond nitrogen, and that is the saturated nitrogen. So we got clear with this example that which one is a saturated nitrogen, which one is a unsaturated. Unsaturated means double bonded nitrogen. So we should have to start a numbering by this rule by saturated nitrogen. So in this case the way of numbering we have to give, that will be, this is the 1 2 3 4 5. So 5-membered ring, first position will be given to the single bonded nitrogen, and next we are proceeding numbering so that the next nitrogen, which is again the unsaturated nitrogen, will get the list number. So this is the anti-clockwise way of numbering, is the correct way of numbering. So by this way we had seen various rules for giving numbering to the heterocyclic rings, and mostly these all are simple heterocyclic rings, single ring structures are there. By the first rule we should have to start with a numbering with the heteroatom, go clockwise or anti-clockwise. Second, if there is the presence of substituent, then substituent should bear the list set of number. Then third one, if more than one substituents, we should have to get the last substituent should get the list numbering, set of numbering. Then by this way, by OSN rule, from which heteroatom we have to start the numbering. And if more than one nitrogens are there in the heterocyclic ring, then which nitrogen will get the position 1, saturated or unsaturated, will tell by these rules. So all these rules we have to follow while giving the numbering to the heterocyclic rings. So thank you so much. We have completed this part 2 and next part we'll see various rules for giving, naming, and the different examples of heterocyclic rings. Thank you so much.